Hi everyone, this is Gaurav and welcome to my channel. So in this video, we are going to discuss about NumPy. But before I go any further, I just want to quickly call it out that NumPy and Pandas, these are the two things that you will be using quite a bit as a part of your data science journey. So it's kind of really important that you understand this through and through and get very comfortable with it. So in today's video, we're going to discuss some of the basics, but as we move forward, once we start to solve some of the real life problems, then we will be exploring some of the additional features as well. So, but first and foremost, let's take a look at the dictionary definition. And this is the definition that I copied from Wikipedia. So it says that NumPy is a library for Python programming language, adding support for the large multidimensional arrays and matrices along with a large collection of high-level mathematical functions to operate on these arrays. Pretty self-explanatory. But if I have to kind of rephrase it, then I would say that when you're working with a multi-dimensional data, like so say for instance, if you have a customer data where you have dimensions like age, income, your overall spending pattern across different months. So if you're working with a data where you have multiple dimensions, then in order to do any kind of a simple processing, NumPy does help a lot. So as we move forward, I'll definitely be showcasing that how you can do the same or similar exercises using something like list as well. But as and when the dimension of the data or the size of the data increases, then you will see that it becomes extremely difficult to process the similar information or do the similar task using list. But essentially, it does become like a fairly easier if you are using something like a NumPy array. You can refer to some of the documentation as well, where you will see that people have done experimentation where they pick like a big multi-dimensional array and they showcase that if you are using something like a list, then it does take like exponentially lot more time and computer resources to do a simple calculation as compared to NumPy array. So the overall implementation is also much more efficient. So in today's video, first of all, we will start with defining what NumPy array is. How do we simply define it? And then afterwards, we will be comparing it with your list. We will also see that how can I convert a simple list into a NumPy array. Then we will dive into the multi-dimensional NumPy arrays. We will try to access some of the data out of it. We will also try to filter some of the information. And in the end, we will try to edit the new multi-dimensional NumPy array that we have created in the earlier steps. So first thing first, whenever you are using NumPy arrays, then you have to call this function in your memory. And the way to do that is by using something like NumPy, import NumPy as NP. Now, if you run this code and if you run this line of the code and if it does run successfully, that means that NumPy is installed on your computer. However, and that will happen by default if you have installed something like Anaconda, which is what I'm using. However, in case it is not installed and you are using some sort of other ID and it's not installed there, then it's kind of very easy to install it. All you have to do is just go to your terminal and use something like pip install NumPy, and that will go ahead and install it. There are multiple videos out there, multiple resources out there on the internet. In case you do face any difficulty, accessing any kind of a NumPy content, do take a look. Usually, it's just some sort of an installation issue. But given the fact that NumPy came like so early on, all of the latest version of the Python usually comes all pre-installed with NumPy. So most probably you will already have it as a part of your base installation. So let's try to define our first NumPy array. Let's say it is np1, and the way to define that is going to be np.array, and then you just define the list of data that you would like to be part of it. So let's say it's 1, 2, 3, 4, 5. Now let's take a look at the content of np1. Now as you can see that it says array, and then you have a big bracket here, and then you have 1, 2, 3, 4, 5. So it kind of does look very similar to what you have as a part of a list. So let's say that if I have to define something called a LST1, which is your list, I'll probably be defining in a very simple, similar way, which is I'll be putting all the content as a part of your big bracket, and then overall content. Let's say if I have to print it out, you will see it's kind of very similar. The only difference here is going to be if you have to just take a look at it prima facie. If I have to take a look at shape of np1, then you can see that it says 5 comma. However, if you have to take a look at the shape for the LST1, it will just tell you that it has like 5 different elements. So I'll explain what this 5 comma is in details as we move forward, but for the time being, you can assume that the first element that you have before comma is your number of rows, and anything that you have after comma is going to be your number of columns. So once we start defining something like a multi-dimensional arrays, then it will become much more clearer. But before we do so, let's try to define some of the other NumPy arrays. So first and foremost, let's say I have to define another NumPy array, which is not exactly, you don't want to write the data, but you want to kind of define it as a part of your normal integers. So you can use something like a range. And this is kind of very similar to what we have defined earlier, which is range. So you can you can specify the start and end. So let's say I don't want to specify any of the start. I just want to have it like 5 different elements. And let's see, if you do this, then you will see that it's kind of exactly the same as you have here. You have 5 elements, but I don't have to kind of go ahead and call out all the different elements. You can convert a list into array as well. So we did define a LST1, which is your list. Let's try to convert that. So let's say that I want to define another NumPy array, and I would like to convert this into I would like to convert our list into a NumPy array. So way to do that is going to be very simple. You will always keep on calling out np.array, and let's say we do it this way. Let's take a look at the content for MP3. As you can see, it's kind of exactly the same as you had earlier when you defined something like a NP1. So basically, your list has been converted to a NumPy array now. Now let's dive into a little bit of multi-dimensional NumPy array. So for that, let's define 3 different lists. So you have list 1, and let's say the content is 1, 2, 3, 4. And then you have list 2, which has a content of 5, 6, 7, 8. And then you have list 3, which has a content of 9, 10, 11, and 12. Now let's say that I want to define a NumPy array, which is NP4, which is nothing but NumPy array, which is a combination of all the 3 elements that we see as a part of LST1, LST2, and LST3. Let me just quickly write it. Okay, perfect. And let's try to see what is the content of NP4. So when you do it, as you can see, that you have 3 different lists. So you have LST1, 2, and 3. Each one of them have 4 elements, 1, 2, 3, 4, and so on. But what's happening here is that you are defining a NumPy array, which is a combination of your list 1, list 2, and list 3. So it's kind of making like 3 rows, first list followed by second list followed by third list. And that's what you can see as a part of this new array here as well. So let's try to see the overall shape of NP4. And now as you can see that it has 3, 4. Now what 3 is the number of rows. So it's like 1, 2, 3. And then you have 4, which is the number of columns. So you have 1, 2, 3, and 4. It is kind of very important to get comfortable with the concept of multi-dimensional array and also understanding how would you access the overall content of array using the different indexes. In order to do so, it is important to understand what this 3 and 4 stands for. So as I mentioned, it is your row 3 and column 4. Now, once you have defined something like this, then you can access the content of NP4 very similar to the way you would do it for a list. And it's kind of also very similar, even moving forward within pandas as well. So the way to do that is that first of all, let's say that I want to go ahead and access the first element. So I will have to first of all specify what is the row number and what is the column number. So in this case, this is 0th row and the 0th column. I mean, it's like first row and first column, but given indexing starts from 0, so you will write 0, 0, and you can get the first element. But NumPy also gives you the flexibility of editing. So these are pretty much everything that you have as a part of a NumPy array is also mutable. So it's not like once you have defined it, it's going to be static. So let's say, for instance, in this case, For this first element, I would like to go ahead and change it and make it, let's say, 99. So I can go ahead and simply do that by calling np4 0, 0 is equal to 99. And now you will see that overall the content for np4 would have changed. And the first element has now been converted into a 99. So you very simply put, by using this indexing technique and using these indexes, you can access any part of the data in your NumPy array, and you can make some edit, you can access that, and you can put it into another NumPy array as well. So let's try to do that. Let's try to put the content in another array. So let's say that you have np5, that is your new array, and then you would like to go ahead and take these 4 elements. The way to access these 4 elements is going to be that you will tell the system that I would like to have an access to first row, but only first 2 elements, and then the second row, only the first 2 elements. So the way to do that is going to be, simply put, you will first of all write the number of rows that you would like to have and number of columns that you would like to have. So you want to start from 0, but you want to go ahead and go all the way up until here, which is the first 0, 1. But here, as I have mentioned earlier, that whenever you are doing any kind of indexing in Python, the first element is going to be included, the second element is not included. So it's like greater than, equal to, and less than. So here you will mention something like 0, 0 colon 2. And then again, you will do the same thing here for number of columns as well. And if you do that, let's take a look at what do we have as a part of np5. As you can see that these 4 elements have been copied to your np5. And this is kind of very important, because think about it. Let's say that if you're working on any of the exercise and you have like multi-dimensional array, and each of the dimension might actually represent a customer attribute or a particular customer itself, and you want to access one particular part of your array, and you want to say that, well, let's just go ahead and filter it out and put it in another array so that I can go ahead and do some additional calculations. So some of these functionalities will definitely help you. So first of all, what you can do is that you can use something like an index here, or you can also do something like a simple number filter. So let's say that you define np6 and you want everything that is a part of your np4, but you want np4 which is less than np4 for all the values which is less than, let's say, 7. So you can do that as well. And then let's take a look at the overall content for np6. Now, as you can see that it will kind of give you all the elements that you have as a part of np4, but it has a value less than 7 that will be copied to your np6. Now, one thing that you can see that np4, which is your NumPy array, has a particular shape. So it has 3 rows and 4 columns. NumPy also gives you a flexibility of changing the overall shape of a NumPy array. So you don't necessarily have to stick to like 3, 4. As long as the number of element remains exactly the same, you can convert it to any other dimensional array as well. So let's try to do that. So let's say that you want to define something like np7. And here you take np4 and then you can use something like reshape, and then you will say that rather than having 3, 4, which is 3 rows and 4 columns, I would like to have 1, 12. So I would like to have just 1 row and 12 columns. And let's take a look at the content for np7, which is your new NumPy array. Now, as you can see that the total number of elements has remained the same, but now pretty much everything has flattened out. It has converted to like a 1-dimensional array. And then you have all the elements as a part of like a 1-dimensional array. You can convert it back to whatever shape that you want. Now, let's try to convert that. But rather than saying 12, let's just say that I want to kind of go ahead and do it only for 11. And then you will see that this thing does error out. And the reason why it errors out is because whenever you are doing any kind of a reshaping exercise, NumPy will not allow you to convert it to a different shape if it does result in any kind of a data loss. So if you do want to change anything, first of all, you have to kind of make sure that the overall shape, overall number of elements that you have in the pre and post should remain exactly the same. If you want to drop some data, then first of all, you should drop the data, and then afterwards you should do the reshaping exercise. Let me just quickly check. We have looked at editing, you have accessing, filtering, multidimensional arrays. I think we have covered pretty much everything else. here. So that's pretty much it for today. Thank you so much for being with us. As we move forward, we will be diving into the pandas data frame from next video onwards. If you do have any questions, please feel free to drop it in the comments. And if you haven't already, please do like and subscribe. Have a beautiful day. Thank you.